Well, I appreciate y'all coming out. We're going to talk a little bit about the technologies that are out there, how some of the ASHRAE codes are changing a little bit. I'm not the ASHRAE expert, but I do know a little bit about what's going on from the government sector and some of the private sector, large institutions, and some of the other changes that are going on within the ASHRAE codes. I know there's a lot of changes. A lot of you all know that there's a lot of changes. Some of the big aspects in regards to airflow technology has been a very big hurdle for a number of TAB, commissioning, as well as automatic temperature control contractors. So a part of my compassion for the last 30 years in the industry, growing up in the automatic temperature control world as a contractor, manufacturer, commissioning agent, working with the design firms and the end customers, I've developed this in talking and putting things together from past experiences that I hope will help every aspect of who I pointed out to minimize some issues so that we can perform a better project with our customers, so that we can get it on and off the job better and be able to provide a more reliable service, as well as our staff and people will know what to look for, maybe expedite things in a more professional fashion. Not that it's unprofessional, but obviously you probably know that sometimes that there's things that are done unprofessionally out in the field. I was trying to find some interesting pictures that I ran into, but I seem to have deleted those from 30 years ago. One of the biggest things I remember was being called in. The TAB guy was not one of the best in the area. He was low bid, of course. And we got called into a conference room, and there was footsteps all across this $50,000 conference table. And they tried to blame it on us, the temperature controls guy, but all we had was a sensor on the wall. But what was interesting, and I was able to point it out, right above two positions were the diffusers, where the TAB guy had come in the night before and had done his hooding of the diffusers. And right below those is where he would so nonchalantly be standing in all of his footprint, so they were had to foot the bill for a $50,000 conference table. So hopefully we can address some of those concerns with some of the newer technologies, some of the easier ways to measure and be ahead of the curve. So we're going to get started here a little bit. Hopefully I won't have to refer to too many of my notes. We're going to rip through some various energy agenda items, airflow technologies and how they operate. Some of you all, this might be what you already know. Some of it, hopefully, you will understand a little bit better why, as a manufacturer, they're doing certain things, what happens on the install, things to avoid, applications and errors in implementing these technologies, startup, testing, troubleshooting the flow equipment and the flow requirements, as well as how they affect the various regulations that will be implemented. I had the privilege of talking with a couple people already in the show about some various technologies, and hopefully we'll address the use of those in these. If not, we might have enough time at the end to discuss some of those applications, or you can meet us out at the booth where I'll be at, and we can go into those details, or even come out and do a training at your facility a little bit more in depth with those applications. One of the big things that needs to be done in every kind of technology is certification. There are a number of technologies that have certification. You go out and get your UL, you go out and get your other kind of certification so that they can apply to that respective application. Airflow side has a third-party application or a third-party company that does the certification for you and will verify not only your documentation but your proof of performance. So you'll take your components out and get it certified. This is not new, but it's new to a lot of the components that we're going to be talking about through the day for measuring the airflow. A lot of components are not certified. They're starting to get that requirement for certification. One of the big things you want to push for and look for when you're out there looking at your systems on the front end, are they AMCA certified? That should give you the confidence that the components that you're going to be working with have been tested against what the manufacturer says that they will perform, how they will be installed, and how they will operate. So therefore, you can compare what's the application, is this the right device for this application based on its certification, what kind of ranges will I be working with, for accuracy and functionality. Am I within the tolerances and within the operating range of the respective air system that's there? They are fully tested. Little side note, when you submit that, usually your engineers will go up there with them and help them get started, so you just don't ship it in a box and then you end up getting damaged goods back because they didn't implement it properly. So it is some sort of training to make sure that your component gets installed properly, and then they can do the proper test and association there. Multi-point measurement. Back in the day, probably, I don't know, how many people have been in the industry for, let's say, 25 years and longer? Okay, quite a few. So back in the day when we were a controls contractor, you probably remember, those of you that might have done commissioning, I remember having to string a wire across the duct and then have to string polytube or bring a polytube out into the middle of the duct to get the pressure sensor to start reading differential pressure or any kind of velocities, and then bring that back. Then we went into some of the pitot tube technologies. If the project could afford it, how would we install it? What would we do? And then again, we were still into an install issue. So at the point we start getting into some multi-point measurement, multi-point measurement gets us kind of distant, gets us an array across all of the duct work so that we can get multiple points, so that we can get an average and we can see the full performance of what's going on within the duct work. Better reading, more stability, more accuracy, so that when you start changing the loads and start varying the velocities of the system, at least you have some sort of balanced flow rather than being off peak, whatever, in your flow parameters. At least you're able to see a constant velocity so that you can do your proper measurement. So the multi-point, either through a pitot tube type system or through a thermal dispersion type system, gets you that more accuracy across that. What that also gets you is in your duct work, similar to mechanical meters in your chill water, hot water, you have the same upstream, downstream type of requirements. They're different than the fluids, but you still have an upstream, downstream because of the way the flow goes through various angles, T's, and the like. So you deal with a lot of the velocity angles that can deviate off of the sensor or transducer that's installed in the field, based on whether it's upstream, downstream, to any kind of positioning within the ductwork. Because as everyone knows, once we get out there in the field, it's not exactly the best environment to install any kind of sensors or transducers, so therefore we have to tolerate and deal with any kind of off-angle velocities so we can get that multi-point sense for better accuracy, better flow rates. And of course, that'll vary based on further downstream, as well as change of the velocity when you start varying airflow. Same thing, I'm not going to get into the disturbance and the airflow directions, positive, negative angularities, but you want to watch for those angularities on those, so that you want to make sure that once those get installed, those sensors and transmitters gets installed, that you're covering the full deck with full ductwork with the appropriate amount of points, so you don't want to be shorted there. Again, we talked a little bit about minimum installation requirements. This is always a nightmare. I know that, let me just ask this question. When you go out and do a commissioning, how easy is it to find 2/3 down the duct length for your differential pressure? I always hated that when I was a contractor installing it. What's 2/3 to us? What's 2/3 to you? You put it in a drawing where it's supposed to go. The engineer does. Not that it's bad, but based on paperwork, it looks great, but what's installed? You could be way off once you get an installed system out there. So how are you playing with that duct work and the positioning of your sensors becomes very critical in understanding the flow of the system. Flow technologies will go into, of course, the ducted airflow, outside air, any kind of fan inlet, and then also the air side economizer, where you have your minimum and then you have your full damper control. So we'll talk a little bit about each one of these areas, specifically within the various types of technology, and looking on how they work and interchange. This was a great job. This is not the way you measure outside air. This was not known to the customer. That was actually going into coming off of the cooling tower platform into the patient areas. They had opened the outside air because they weren't getting any airflow from the sensors. And what it was all the sensors were clogged because they had too much outside air, thus the wedge of the damper actuator. So a lot of people are working into, okay, do we do pitot? Do we do thermal dispersion? Is everybody familiar with the pitot technology, right? That's been around as long as we have. Does anybody not know what thermal dispersion is? Good, good. So I don't have to go into details there either. So when we look at thermal dispersion and pitot, they both still have a lot of value within the various systems that get installed. And a lot of things that we've stumbled onto is, okay, I only want the new technology, I only want the thermal dispersion. Well, that might be true, but let's look at the application. When we get into the thermal dispersion, we don't quite have the accuracy in the low flow range. What are you looking for in that low flow? Does the application require a low flow reading sensitivity so that we have the accuracy, so that we're able to get the readings that we need? If not, we better look at some of the pitot readings. Going to some pitot devices down in that low flow. So you want to look at your application, where you want to read, and how you want to read. Some of the energy projects that we've come up with on the government side, they tend to, it's probably the same in the private sector, they tend to say, okay, we're just going to go in and we're going to put in the new technology, I'm going to put in this meter. Yes, sir. The accuracy down here on the low end, we can get a truer reading down here on the low end of the velocities, but when we ramp up to 100%, then we start getting up into the higher flow, into the higher accuracies. So when we want to measure and watch those accuracies in those flow range of those applications, we want to make sure that we get the right sensor, the thermal dispersion or the pitot, for those respective flow ranges. So one of the things that we started looking at in the energy world, when we start getting all these new technologies integrated into existing systems, we start looking at, okay, I only want to look at the high energy, so they look at, okay, full flow. What's going to happen in my low flow? I drop down to 0, or I start losing my accuracy reading, when that might have been the actual critical nature of the system. So that's one of the things you want to watch for when you go out and start looking at the systems. That we ran into some problems as a commissioning agent, is that the sensor and transducers were okay for the full range, but in the range of our sweet spot of normal day-to-day operation, we would lose those values and or those rates as well as the accuracy. So we want to watch and pick out the better angles of what we're looking at. Differential pressure has been around for a long time. Everybody knows that. Depending on where you're at there, it's still one of the preferred methods and angles that the ASHRAE talks about quite a bit. I'm not going to go into the technology. Everybody knows the calculations and so forth and so on. But what I wanted to do was, like I mentioned in the very beginning, is location of the differential pressure 2/3 down the duct and how critical that is to the installation. So those of you that are in the engineering field and those that might be in the commissioning area, watching for that and make sure that there is, based on the actual installation, that the install is done properly where that sensor is before it's all sealed off. On the install side, when we start getting into the pitot type technology and the sensors, one of the things, I didn't want to get into any of the technology of how the pitot tube is made or anything like that. What I wanted to do is discuss the actual airflow and how it hits the pitot tube. Too often we go out and we see the installs all done properly, but once we get into the duct chamber itself, the actual sensor inlets are off a degree or two, 5 degrees, 10 degrees, so that they did not confirm that they were in the proper airflow stream, so that they weren't reading the proper airflow, which is going to throw off your total reading if you got a reading at all. So one of the things that we highly stress to our reps as well as contractors when we're working with them, make sure you follow your installation on it. Look at where that tube's going in. Is it in the proper direction of the airflow, so that you do get your 90, you do get your you're straight on with your airflow depending on the type of sensor and device on there. Use the right components. Such as, you know, sometimes way back when, how many times did we see just a poly tube stuck in the side of a duct? You know, get the right standard pitot tube stuck inside the duct. Look for that. A lot of contractors in the olden days would not do that because it was a cost-saving item. So unless you're really digging into it, you don't see that being used that often, way back when. So we want to watch for those sort of things in the field. Fixed resistance differential pressure is really coming on strong in the area for outside air as well as measuring the systems. Because it's an easier installation, we can look at our outside air, both minimum as well as the full outside air. Some of the newer technologies will sum those together and you can have multiple devices because of the duct arrays. How the inlets, you might have a minimum on one side of the air handler and then a full outside air on the other side of the air handler where they're not blended together. So you want to look at those cause and effects for those different duct parameters for outside air and where it's brought in. With the outside air and a lot of the energy programs, IAQ has become an issue. We're hearing a lot today in regards to Legionella, some of the other contaminants and pollutants in the air getting down into the space that they just don't measure and watch for those changes when they start getting into the airflow changes. So it's a real balancing act to make sure that once you start changing the fan configuration, the air velocities, the volume that's going down into the space, the change of the mission or the change of the application. You know, you might be changing a whole floor of a hospital around to where it's all patients, whether before it might have been OR or emergency rooms. So they're changing that mission. So your air change will change. The parameters will change with that, and that's one of the things that the new ASHRAE codes are looking at, those volume changes. So we want to watch that balancing act between outside air and the mission so that we make sure that we meet the amount of air changes, and we also integrate into any kind of IAQ system to meet the head count that's in there. When we look at the outside air flow measurement with differential pressure across the fixed orifice, which this represents, really looking at it across the whole system. And the reason why I brought this in, it's not in your slide sheet. It was something that came up a couple weeks ago that I thought would be relevant to talk about. We're running into a lot, and we'll talk about it downstream, the type of technology that's used in the outside air. You want to make sure that that outside air measurement device is not sensitive to pollutants or any kind of airborne contaminants, dust, dirt, rain, and the like. We're seeing a lot of some of the other even newer technologies, even though they're installed, they're either getting dirty, they're getting clogged, the electronics are getting wet. So you want to make sure that you're looking at the right component installed there, because obviously it might be working while you're doing your commissioning stage, but thinking about the customer downstream and the functionality of the system as to how it will function when they really start using the system. You don't want it to go haywire when it's raining or have to go up there and clean it regularly. So you're going to look at the differences of those technologies. When you look at this type of component, the outside air DP kind of pressure across that plate, those devices are made for that environment. So you can use those devices for measuring that flow. And we highly recommend it. You don't have to worry about your duct lengths up and downstream. You just have to worry about being able to get it installed onto those louvers, depending on the design and what you're able to do. The challenge, of course, on outside air is making sure that you have the low velocities covered. We talked a little bit about that with the right components, be it pitot or thermal dispersion. Directional and variable wind loads, that's another big issue. Some of those units you have to be careful of that we've run into. We talked a little bit about Legionella. Based on being up on the roof, you might have a cooling tower over there, and once they start getting some condensate clouds going, you're going to be sucking that in, so you want to watch for some of those items that will be going on. Ambient temperatures, again, this could be a big issue. I was talking with a gentleman from Alaska earlier. I didn't even think about going down to -70 degrees, that could be a big stop for a system depending on how you're configured. But you want to watch what your configuration is there, make sure your sensors are able to go to the extreme limits if that area of the country should so be just like Alaska, -70. Also watch for your humidity. Make sure your components are sensitive to the humidity side. We mentioned airborne particles. And then, of course, no straight run or ducts are an issue within anything that's mounted out there. So it's a very good technology to use. We mentioned the various components. You either have the air inlet flow, which is a probe, or you have the outside sensor, which has the two devices built into the head, all going to the electronics unit, which, of course, would be in a secured area. Great thing about these, if you have multiple air inlets, if you're modulating and you can step up into from the minimum into a full outside air, but you have multiple duct changes, you can always add those together, sum those together through either piping or through the electronics. So it gives you that flexibility there. But you always want to look out and make sure that they are properly piped, properly set up. Again, this is another area that we have had some problems where some people think that polytube is still okay up on the roof out and exposed rather than any kind of copper or a hard piping. Again, this is another different type of configuration. And then you also can have the outside air station full assembly inserted into the ductwork. One of the things you want to watch for in this when you're configuring it is making sure your ductwork is encapsulated properly for the install for the mechanical contractor so that you get that full fixed ID that the whole system has been calibrated on and not enclosed and cutting that off for the proper flow. And those, again, are things to look for when you're starting up the system that could cause and affect, why are my readings so off? Why is the system so off? You can come up with these answers and solutions in a relatively fast way to protect the customer. Thermal dispersion airflow. This is a great technology. It's all based on the anemometer technology where you have the differential temperature across the sensors. Of course, some of the areas you have sensitivity to moisture, dust, so they'll have to be cleaned, or the electronics could fail. Those are things that you want to watch for based on the technology or the manufacturer and how it's used. These we call the sensors, and the airflow across the sensor is critical. Some have square inlets, some have curved, some have bells. It all depends on that technology, on how that airflow goes across there. Some are good, some are bad. It just depends on what the application is and how they receive that electronic signal and process it within their controller. Again, just like in the pitot tube, you want to make sure that array, that probe array with all those sensors on it, is orientated properly so that you have the direct airflow across the sensor. Some of the duct inserts or the probe array inserts, they could be off 5 degrees, and that's the way the manufacturer requires it, whereas we're looking at it, we think they need to go straight across the probes so that you have it, but the manufacturer might have to have it at a 5 degree or a 10 degree off axis angle, but it should all be marked in the installation manuals as well as on the components themselves. So those are things that you want to watch for in making sure your airflow is going across the aperture and the installation of it's proper. Great thing about the thermal dispersion technology is a lot of the systems, they pull in all the data so that if one sensor should go bad, it's taken out of the average, it's taken out of the values there. Some will allow an alarm on it so that the user knows it. You also have the ability to see what your cross-sectional temperature is so that you can see what's going on totally in the ductwork. It's a great technological advantage. It's always great to use those as a part of your supply air or your outside air intake temperature measurement so that you can use that in your control apps. Again, this is a look at a typical probe array with three sensors all molded in with the electronics on the head. Various types of technology. We'll talk termination technologies, anything from a Cat5 to RS-485. Let me mention something here. I didn't see it I got it in my notes, but I almost forgot it. One of the things we want to make sure of when we're installing these is that the other side is connected. We've been out to a number of sites that they can't get access to the other side, so they think that force against that duct is okay. So you want to watch for that, because once you start getting that vibration either on the pitot tube side and or on the thermal dispersion side, you'll start wearing the connection out, you'll start getting vents. Your electronics should be fine, but then your multi-point might be vibrating around, so you don't get a steady read on those respective sensors. So you want to watch and make sure that both sides get terminated. Your bolt on the one side, and then of course all your screws sets on the other side. That we've seen that all too often. Of course, they all go to a flow transmitter, which has a display on it, local display. The great thing about the flow transmitters with the open protocol, now we can see either at the display or see back at the building control EMS system. We can now see all the data within that duct system, temperatures and velocities, to see how it's performing when it was installed. All the temperature, all the information is displayed there, which makes it really nice. Some have analog outputs, so that if you just wanted to see the velocity into the system, so that you can just see the velocity over the range. Everyone knows that once you get out in the field, sometimes the ductwork looks different than what was done in the drawings. Some of the systems that you might come up on, this whole control side might have to be changed quite a bit, like the 2/3 down the duct stream, or even in this situation that this customer ran into here. The initial design was that they were supposed to be 2 probes coming in from the side. And that's the way the engineering firm wanted it, with all the respective sensors installed in it. Well, once the contractor got out there and saw, wait a minute, we can't get it in the side here because I have 5 inches on this side and I have none on this side, and that's what, I think it was a 6-foot duct there, 6 by 3, I think. So they had a problem there. So what they were able to do, in keeping with the amount of sensors, they were able to change the design, still transverse across the same duct area, and get the same readings. So you want to keep in mind that you might get out there and your drawings show one thing, but the install is a different way. So that's where you'll want to look at it and see what the cause and effect was. Verify with the manufacturer that, okay, we changed the area penetration. What did it do to my sensor array? What did it do to my components? Did that change? So we want to watch for that to make sure that it still meets it. And in this criteria, in this certain circumstance, it does, because it still met the cross-sectional application. Again, the same thing with the outside air, and also with the pitot tube and the thermal dispersion. When you get into a manufactured flow station, again, you want to make sure your ID of the flow station is met, that the ductwork isn't outside of the frame or too far inside of the frame, because you're cutting down your ductwork, you're cutting down your flow, your whole transverse. Get your honeycomb in there for a straightener, depending on what your accuracy that you're looking for, and your pipe, or not your pipe, your duct upstream and downstream. Again, your electronics, similar to the previous, your electronics could be either local, with the transmitter local, or it can be a remote. So it all depends on the installation where that will be. So you'll look for all that and make sure it's all done. Obviously, you start doing these sort of things, why put a display when it's up on the ceiling? So then you want to make sure that it gets down there for you to properly use. Also, the good thing about being there local, you can see exactly how the configuration is, whether I've got 2 probe arrays coming to this one display transmitter, or I can have 3 or 4. So those are things that makes it a little bit easier for you to do startup and commissioning on. Fan arrays are becoming more and more the thing, especially on the government energy side. They're starting to change everything out to fan arrays. To me, the jury's still out. I get what they're trying to do. I'm just not sure whether in the long term it's going to do what we're hoping it would do on some of the retrofit projects. because we're running into problems where they could not meet total CFM. They were designed to that, but they shorted themselves once they really got into the heavy loads and full systems that they didn't know existed out there. So you just got to play with it and see what's going on there. With the fan array, be it a pitot tube or in this case the thermal dispersion, the thermal dispersion or the pitot tubes can come factory mounted, as this one is, or they can be field mounted. Once you get into the field mounting, now you're going to possibly run into some errors and some possible problems there. Because like in the factory mounting, you have proper placement. You have proper placement in the inlet, as well as placement of the probe sensors across section. So like in this case here, they had to contend with modifying this in the field around the motor shaft and the blades, and hopefully the fan wasn't running then. But then now I've got to measure and calculate where does my sensors go. So now when we get into field retrofits, adding these type of sensors, you've got all those critical items to watch for. You also want to make sure that they're set up, they're square, that all the nuts and bolts and screws are tight. So as an installing contractor, this becomes a nightmare in a retrofit field. As a commissioning type person, now you get to play with this in the field, and whether they allow you to adjust it and make proper adjustments, that's up to your contract and how you want to use it. But this, to me, can be a little disconcerting. I get what you got to do, and I get the customers want it, but that's some things to watch out for. We've seen a combination of misalignment, so that your mounting brackets are not 90 degrees to the manifold and the frame. And then we've also seen where the sensors themselves might be off center and not square with the way that the airflow is supposed to be across that face. And that has thrown off a lot of readings and caused a lot of nightmares of people going back to have to resurface a project. Same way with pitot tubes. You've seen the pitot tube with a high and low where you pipe it in and connect across. Very similar to the other with the thermal dispersion. Also available in stations. Same issues where you have the ductwork, the duct size, the framing of what's going on so that you don't block yourself off. Static pressure sensor. This is always, with the 2/3 down the duct, and then also you got on a high-rise lobby where you start dropping pressure sensors down in the lobby and you try to find the best place to locate it and the like. This always becomes a nightmare, I know, for the controls contractor. That's why we'll refer to usually the engineer. Where do you want it? Let the monkey sit on his back, so to say, of exactly where you want it so that it doesn't get located 2 or 3 times. Very sensitive type of devices. A lot of them have the cosmetic feature set to them. Want to watch for it, the location, and make sure that they're not affected by your elevator shafts, your doors, and any kind of downstream renovations that they might do to any new tenants coming into the respective floors. A number of manufacturers have active test chambers for these various technologies. You have your big built-up air handler, and then you have your other type of duct structures and alike. These are great to get out to, depending on the technology and the provider. Get out and take a look at what they have. Look at the various technologies that they sell, be it any kind of outside air, thermal dispersion, or pitot tube that they might provide. Get out and take a look at their systems. Most manufacturers will provide a training for you and for your customers if they wanted to be at, and get into the technology. See what the cause and effects might be. See the accuracies of the various flow ranges, all of it in parallel. See those systems. These are some of another manufacturer's test jigs. They test all their systems before they go out. Same way with the fan inlets. Startup and testing. Some of these systems, depending on the manufacturer and the provider of the technology, will provide startup support. That's always great in these advanced systems, especially you start getting into the BACnet, Modbus type of technologies that will help you more efficiently and see what the data is so to be more accurately, and you can go across your data as needed. Schedule it in advance. A lot of these guys are very busy just like you are and have a lot of different customers around the country that they're out there. So obviously get that scheduled in advance. Testing. This was always a big issue as a manufacturer as well as a contractor. Once we start going out and start doing a commission and start checking on things, we had some of the suppliers void warranty. And even though we were might have been just measuring voltage across their inputs, the analog inputs, they would void warranty on us because they needed somebody there just to supervise that. So watch for that in today's climate, as well as if you have to reposition any kind of sensors. If you find any sensors, or like when the probe arrays are not terminated properly, see what's going to happen if you have to make those adjustments. I would always recommend that you bring in the contractor who provided the goods to make those adjustments. Know what you're doing beforehand. Again, referring back, manufacturers will provide training, technical training on the system, what to expect, how it works, and how it all integrates together. Most all your manuals are online also, so get that way ahead of time so that you're familiar with what's going on there. Most of you guys already know this. Training corners from manufacturers. The newer systems have startup menus so that you can do a proper startup on the system, and it'll go through the whole check and balance for you. So it verifies the sensors are reading the proper values, temperature and pressure and velocities. So look at your startup menus. Go through the startup program with that. Might be effective enough for you to go through as the contractor who's installing it. He should go through this before you get there, of course. It might be cost effective, I'm not sure with your contract, whether you're there alongside of him to go through these startups with them. That might be a little bit more cost effective and efficient for you to get those items done ahead of time. Like we found with some manufacturers, even though they have the same controller, different generations or different tweaks of the same controller, not all terminations are the same. So make sure if you get into any kind of electronics checkout, where you might be running it and just looking at the voltage levels to do a cross voltage check based on the readings, just make sure where you're at because of all the various types of I/O that might be associated with those type of controllers. Great things about the display, especially out there in the field, many will have kind of alarm conditionings and navigation errors, issues for you to follow. So it will help you expedite your checkout and startup of your projects. Again, get out there and learn these systems and make it a whole lot easier for you all to do. Display errors, again, you have the display errors based on the type of failure that it is within the system. And then we have the protocol data. With the building control systems as they are today, most of them have some sort of open protocols with them. Hopefully most of the airflow systems that you'll see have an open protocol element to them, BACnet, Modbus, LAN, and the like. So use that protocol data to your advantage also in producing a report from there and then see how it cross-references either to if you're hooding the system or if you're doing any kind of measurement, voltage, flow ranges where you might be bringing in your own differential pressure devices to see what's going on. So use that to a great extent. Most of them are read-only. Some of them allow you to put in data. It just depends on the type of system and what their application is. So I highly recommend getting familiar with the BACnet and Modbus protocols if you can. That could be a time saver. So we get into some of the changes within ASHRAE. And the tough thing with ASHRAE, which everybody knows, is anybody here from ASHRAE? Okay. Are you a member or are you? Okay. Excuse me, most all of us are some sort of member or attend the ASHRAE functions. It takes, like the government, it takes a while to get things through ASHRAE. And then sometimes they get through ASHRAE, and then it's like, okay, well, it's recommended. I'm dealing now a lot with that on the Legionella and contagious disease area that I do consulting work on, and making sure that all those requirements are done. So when we get into 62, a lot of changes aren't happening. Obviously, it prescribes ventilation and rates depending on the type of structure, occupancy, not mandated airflow measurement, requires maintenance, minimum outside air. So it has all these great things to do. They are making changes in a number of these ASHRAE components based on the type of mission, whether it's an OR, whether it's a patient room, whether it's an office building, and then the automatic adjustment based on personnel inside. So there are changes coming down. The big thing is what is the state and local really going to require to do? In the government, it's usually recommended. We're starting to see some of those changes from recommended to shall and will, with the definitions of shall and will. Simply because of the older buildings, when you get into them, what they have with the Legionella and the contagious diseases that are involved with the older ductwork and infrastructure that's there with floating around. So, and then we get into 189, the high performance green buildings. Does anybody deal with this ASHRAE code at all? Okay. Yeah, this, you have a question?
What is stress? Yeah, I think kind of going back to what the authority recognized outside of the lead requirements for commissioning.
Yeah. The government is really strong on this one because of the sick building syndrome and then the energy performance that they have to do and the requirements. So with that, they're bringing in more outside air. And then that outside air is going to change obviously based on the environment, whether it's north, south, east, west, Alaska, all those sort of requirements. But it's also important on the mission because you're getting a lot into the healthcare. Anybody within healthcare? Focus on healthcare? Okay, the healthcare is really changing a lot for the good, I think. I mean, not that it's been bad, but there's a lot of air changes that are coming up and requirement on multiple air changes that they're finding and purification that will be migrating into the various codes. Green building is pushing a very similar type thing because of the amount of government buildings, the older government buildings that have had sick building syndrome. So you'll see a lot of the changes there, adding that down based on the head count as well as the volumes of the system. It's going to cause some havoc based on some of the earlier designs and the way that the system's designed, so look out for that. 90, we start getting into some of the energy standing, setting up minimum building requirements again. 55, indoor air comfort. We're starting to get into temperature. You know, one of the things that we were concerned about when we were talking with ASHRAE and on the energy side is, okay, we're going to start doing temperature mandates. Does anybody remember the temperature mandates? What was it, Carter administration? Pardon? 78, 68. Yep. And that's kind of getting some heads turned again, especially in the government and state side, because they're not meeting some of their energy goals with some of the energy systems put in. So they're looking at some of the indoor air comfort. What can we do for outside air? What can we do to change some of the air systems and distribution to keep that temperature capped at certain rates and certain levels? So these are changes that are coming down. I believe 189 is going to have some changes that are published this summer. 62 is, I believe, in the fall. They've announced that there's going to be some changes. There was already some clearer definitions that were sent out. They're looking at some changes, and they're probably more wording changes like the will and shalls and the like, because it's been kind of loosey-goosey on our marketplace. Mm-hmm. Here, I'm going to do two hats. I'm going to go back to my temperature control guy. Okay, and the way it was always defined way back when, and of course we know that sometimes codes and specs and ASHRAE requirements don't come up with the system and don't follow through. In the temperature control realm, when we're at outside air, we're in cooling. We shouldn't be doing any heating. That's the mental logic, right? So therefore, when we go to set our outside air parameters, it's always 24/7. Should be, because that's our minimum outside air that's required based on the occupancy and the mission of the area that it's served. So that should be fixed no matter what. As soon as the unit comes on, we go to minimum outside air. And then based on temperature, if it's freezing, that should throttle back so we don't freeze coils and or we start an overheat process. So now, once we get into where we're heating, we still have a minimum outside air, so we're still going to be bumping up those dampers to certain positions because they want to recirculate and keep that fresh air in, and that becomes the control logic and thought that we still have that IAQ, we still have that fresh air requirement unless something is changed in the spec and it's clarified from 62 into the sequence of operations.
The majority of the time they're not modulating it. They're starting to modulate that outdoor air damper. The majority of existing buildings, the minimum, they're not opening it
That's,
upon heating.
yeah.
So they're going to change that going forward.
That's, they're supposed to change it to that, and based on, oops, I hate this device. This is the current requirement, right? This is straight out of the manual right now, okay? As a part of the energy efficiency and the mission, they're looking at modulating that once we get down to a heating threshold that we cannot maintain. So that if we don't want heating and cooling. And so the sacrifice is, okay, then we're going to start throttling back the outside air damper. The downside of that is we lose that fresh air. But if we're still sucking in all this outside air and it's super cold, our heating capacity might be blown away. Which in a lot of cases, that's why we have little local portable heaters in people's spaces. Yes?
As a commissioning agent, the biggest problem I find with airflow monitoring stations is how do you field verify the accuracy? Because they're very rarely, let's say never, in an ideal location. And the instrumentation that a tab contractor has, therefore, does not work in those type of applications as well. And then sometimes tab contractors try and field calibrate them, and probably make it worse. So do you just trust the manufacturer? Or how do you go about verifying and field in a bad location?
Good question. Because I know most TAB, you're out there with the hood, you're out there with your differential pressure. So using those components can get you some of the variables in your flow. You're talking about like the thermal dispersion or pitot tube type technologies, right, to verify those? So you can use those tools to get within the various parameters to know what you should be getting for a signal out of those components. Some of those, obviously, based on the location, whether it was installed properly, so forth and so on, can vary. One is hopefully it's within the accuracy that you're allowed to on the TAB, and hopefully it's within the accuracy of the manufacturer's requirements. Obviously, if it's not, now we've got to look at install issues. There are some systems that allow you to tweak the various factors internally to get within that tolerance. And that gives you the ability to get within that range that you need to be operating. Now, if you're way off from what reality is, now we've got to start looking at installation problems. Do I have a ductwork problem? Do I have an install where my sensor arrays are off center? They're failed. You know, so there's those two different issues that you got to look at when doing that. Yeah, and that's the biggest thing is we never have this, you know, the right ductwork. It's never good. It's great on paper, but it's never good once you get there. One of the things, of course, this isn't relative to you all, but it is something that some companies will provide. Maybe you all will also provide, and we run into this a number of times on renovations where we go in with new systems, whether it's mechanical metering or duct systems. Is that the customer will go, or the mechanical or engineer will go, I want it there. We'll go, no, you can't put it there because of this, this, and this. So getting the expert of that type of technology out there, if it's an existing system, to find that best place. Because they might say it's going to be there, well, wait a minute, if we put it on that side, you're going to get a better stable, more accurate reading. And it's just a matter of moving it a few feet or into a different area and still get the same amount of proper readings. Might even have to split up and do two different stations to get a total sum. Just depends on what the system looks like. Air is always tough. It's a real tough test and balance. Any other questions? Yes.
Problem is, according to ASHRAE standards, to get the accurate airflow readings, you have to have a laminar flow.
Yes.
If you have a turbine flow, there is no way that you can get accurate readings. The location that you was talking about here for the outside air, fan inlet, all these locations, the flow is turbulent. So there is no way that you can get accurate readings, and there is no way that you can even verify that the reading is accurate.
You're correct. If that's a question.
And that's our problem now, because we can't verify that any of these projects are maintaining the minimum ASHRAE outside air requirements for any building.
Sure. Again, once we get into measuring the respective tools, be it a differential pressure, recalculating back to what your measurement should be, downstream, hooding the environment, knowing what your totals are, seeing what that is, you should be within those relative ranges. Most of the time, your probe arrays and your system that gets put in properly, and I use properly kind of loosely, you're within their defined specified range, 5–10%. I would. Yeah. Yeah, there you have a problem. There you have a problem with the install, whether you have enough laminar flow or whether you have a device that's installed improperly, as well as you might have a signal conditioner out of the transmitter. One of the things that we as a company run into is we might provide these devices, but then they might go to some clearinghouse parts list and buy a $200 transmitter that's 10 or 15% accuracy. So you have our 5 or 10% accurate device going into a 10 or 15 accuracy device. So how far are you going to drift off picking all these cheap low-end components that aren't a part of a real manufacturer's product and solution to meet the 2, 5, or 10% accuracy? So you've got to watch for those things too that occur. And that happens a lot in our industry where okay, I'm just going to go down here to this catalog shop online. Instead of buying your $500 1% accurate, I'm going to just go buy this $200 3 or 5% accurate. I'm okay with that. You might be okay, but is the operation okay with that? And then it's just missed because they're really looking at the system overall, which they expect is what the package was, in this case, the flow system, the airflow system. And then again, once you get into the multi-point, you can get into a good understanding of what that flow is doing across that transverse duct to see what's going on there. We've had one customer that built an insert, and he has this testing tool to do his balance every so many years. He's got a duct chamber. He'll just slip it in there, check his readings, pull it back out. He's good to go. Everything's looking good. It's what it's supposed to be doing. It's at the parameters that it's supposed to be at. So he's built his own duct insertion array to do that. Questions? Any further?
On the fan inlet, have you had an opportunity to compare the, I call it the hot wire, but your thermal dispersion with the piezoelectric flow meter?
Adrian, help me. The piezoelectric, did we do a cross comparison to those? They're similar accuracies, am I not correct? Much direct in, because it's down in that tube, right? Down in the chamber? It's what? Lower accuracy? So you're talking about, let me get over to it. So you're talking about like right down in here where the piezo will be a ring around the ring, and then you have this here. That is okay. It's not as accurate as when you get to the thermal or the pitot tube, because these are out in the airstream. Here you're dependent on the vortices of the airflow and the draw through here, through the pitot. So does that answer? Yeah, we can get that as needed. We've got analysis on each one of the technologies. Is that it? Well, cool. Thanks for coming out. Hopefully it helped.